This is problem 31.39, and you're told that you have this flat circular coil like this. It has a radius r, and it has n turns. So it's field in its center. We're going to assume that it's uniform over its area. We are asked to first figure out what the inductance is of such a ring. So we're not actually given numbers for r or n, we just kind of want an expression for this generic type of situation. These are the three equations we need. This is the magnetic field produced by a ring. This is our equation for flux for a very basic scenario like this. And this is our equation for the inductance. So let's plug everything together. So we have L is equal to N phi B over I, where phi B is B A cosine of theta over I, where theta is the angle between B and A, where A is an area vector. We're going to assume that our magnetic field's either going straight into the page or straight out of the page, which is the same direction as our area vector. So that means we can get rid of this cosine of theta. Okay, so now we have this, and then we plug in our value for B, so we get N mu naught I over 2RI. That is going to be N squared, and I forgot the A. N squared mu naught I times A, where the area is just pi times r squared. So pi r squared divided by 2RI. We can go ahead and cancel out the i's and cancel out one of the r's, and we get for our inductance N squared mu naught pi r over 2. Okay, so again, we're not going to be plugging in any number, but this is the expression. If we move on to B, it says that we have a circuit on a laboratory table consisting of a 1.5 volt battery, a 270 ohm resistor, so 270 ohm resistor, a switch, and three 30 centimeter long patch cords connecting them. So we have, if we draw it out, one patch cord, two patch cords, three patch cords, all the same size, forming this circular shape, and there's a switch there, there's a resistor, and there is a battery. But essentially our circle is this size. It asks us to first figure out the order of magnitude of its inductance. So this is kind of a circle, and this is the inductance of something that's kind of a circle too. So then all we have to do is say, well, 2 times pi times r, and that is going to be 3 times 0.3 meters. So then the radius is just 3 times 0.3 meters divided by 2 times pi, and if we plug in numbers, that is going to be 0.143 meters. So we have the radius, and we know that n is equal to 1 as per the question. So then we can take this, take that, and plug it into our equation for the inductance, and then from here we actually get a number. So if I were to do that, I have L is equal to 1/2, n is equal to 1, mu naught is just 4 times pi times 10 to the negative 7 Tesla meters per amp, and then we multiply that by pi, right? Times r, the radius, so 0.143 meters, and that is going to give me 2.83 times 10 to the negative 7 Henry. Order of magnitude, so about 10 to the negative 7 Henries. C then says, what is the time constant describing how fast the current increases when you close the switch? So to get that, we need to know that the time constant is just L divided by R, which is just 2.83 times 10 to the negative 7. And this time R, we're talking about the resistance, which is 270 ohms. That is going to be somewhere around 10 to the minus 9 seconds, so about a nanosecond. Okay, and that is it for this problem.